Let's go ahead and solve this question. It says, find dy dx, given that y is equal to x sine x over 1 plus cos x. Now, we want to find the derivative of this. We want to differentiate this. How do we do that? Now, you can see that this is a quotient, all right? Meaning it has a dividend and a divisor, all right? So, meaning that we can use what? Quotient rule to solve this, to find dy dx. And how do we use quotient rule? We assume the numerator to be u and we assume the denominator to be v. Always. The numerator is always u and the denominator is always v. Now, we know that quotient rule says what? That dy dx is equal to what? V the u dx minus u the v dx, alright, over what? V squared. Alright? So this is how we differentiate using what? Quotient rule. Now, how are we going to do this? We have said that our u is equal to what? X sine x. And we've said that our v is equal to 1 plus cos x. Differentiate this side, differentiate this side. So when you differentiate this side, you're differentiating u with respect to x. And you're going to use product rule. Alright? You're going to use what? Product rule. Let me take this here so that we can see it. So you're going to use what? Product rule. So du dx is going to be equal to what? I said you're going to use product rule. And what's product rule? Product rule says what? V du dx plus u dv dx. That means take the first one, differentiate the other, plus take the second one, differentiate the first one. Now, what do we mean? We mean take x multiplied by, differentiate the second one, which is sin x, you get cos x, plus, now, take the second one, which is sin x, multiplied by, differentiate the first one, you have, if you differentiate x, you have 1. So du dx here is going to be equal to what? It's going to be equal to x cos x plus sin x. Alright? So our du dx is going to be equal to x cos x plus sin x. Now let's find dv dx. Alright? So dv dx, we're differentiating v with respect to x, is going to be equal to, differentiate 1 is gone. Differentiate cos x, you have minus sin x. Alright? If you differentiate 1, which is a constant, you get 0. Differentiate cos x, you get minus negative sin x. Alright? Finally, we have all that we need to be able to find the dy dx of this function. Alright? So we're going to put all of this that we have here into this formula. So what are we going to have? We're going to have it that dy dx is going to be equal to v du dx. Our v is what? 1 plus cos x multiplied by, what is our du dx? Our du dx is what? X cos x plus sin x. Alright? Minus what? U dv dx. Our u is what? X sin x. Alright? X sin x multiplied by, what is our dv dx? Our dv dx is minus sin x. Alright? All over v squared. What is our v? Our v is what? 1 plus cos x all squared. Alright? Now, let's continue. Our dy dx now is going to be equal to what? Now, we're going to open this bracket. Alright? So 1 times this gives us what? X cos x. 1 times this gives us what? Sin x. Alright? And then cos x times this gives us what? X cos square x. And then cos x times this gives us what? Sin x cos x. Alright? Now, minus sin x multiplied by this is going to give us what? Minus. And when with this minus, we're going to have plus. Alright? So this minus and this minus gives us plus. Then x sin x times x sin x gives us what? X sin squared x. Over, now we have 1 plus cos x all squared. Now do not open the bracket, just leave it like that. Alright? Do not open the bracket, just leave it like that. Now, when you're solving some questions sometimes, you have to see the future of the question even before you start solving. Sometimes. Now, I'm speaking metaphorically. What I mean is that from this point now, you have to look deep into the question. Now, you see something here. You see what? X cos square x, and then you see x sin square x. So arrange them together. So write it as what? So your dy dx now is going to be equal to x sine squared x plus x cos squared x. All right. So this is gone. This is gone. What do we have left? We have what? We have x sine x cos x. We also have x cos x. We have sine x. Now, what I'll advise you to do is take your what? X sine x cos x. So it's going to be what? Plus sine x cos x. All right. The next one we have what? We have what? X cos x. All right. We have x cos x. So it's going to be plus x cos x plus. Now the next one we have what? Sine x. All right. Sine x over what? 1 plus cos x all squared. Now just take it easy, take it easy, take it easy, take it easy. Now watch closely. You're going to see that x is common between these two. So we're going to have it that dy dx is equal to x into brackets what? Sine squared x plus cos squared x. Close the bracket. That's between this and this. Now you find out that something is common between this and this. Cos x, take it out. So you have cos x into bracket sine x plus x plus sine x. All right. So you factorize cos x between this and this, and then you are left with this. All over 1 plus cos x all squared. All right. Now, I want you to notice something. All right. I want you to notice something. You find out that, just watch. Recall that sine squared x plus cos squared x is equal to what? Is equal to 1. All right. So meaning I can replace sine squared plus cos squared with 1. So meaning I can replace the whole of this with 1. So it's going to become what? X multiplied by what? 1. All right. Plus what? Cos x into what? Sine x plus x. All right. Plus sine x. All right. Now, all over what? 1 plus cos x all squared. All right. Now, what is going to happen? This multiplied by this, I have x plus. Now, let's open this back again. Let's open this back again. We're going to have what? Sine x cos x. All right. Plus x cos x plus sine x. All right. All over what? 1 plus cos x all squared. All right. Now, if you notice, this is x. And if you notice, this is x cos x. Let them be together. This is sine x cos x and this is sine x. Let them be together. All right. So let's continue. So it becomes what? X plus x cos x plus what? Sine x cos x. All right. Plus sine x over 1 plus cos x all squared. All right. Now let's continue. So it's going to become what? Now watch very closely. X is common between these two. All right. So it becomes x into bracket what? 1 plus cos x. All right. Now if you watch, sine x is common between these two. So it becomes sine x into bracket what? It becomes what? Cos x plus 1. All right. All over what? 1 plus cos x all squared. Now mind you, I can write this cos x plus 1 as 1 plus cos x. So it becomes x into bracket 1 plus cos x plus sine x. All right. Into cos x plus 1 is the same thing as writing 1 plus cos x. All right. Over what? 1 plus cos x all squared. All right. Now let's continue. If you notice, 1 plus cos x, 1 plus cos x common on both sides. So we could bring it out and then we have 1 plus cos x all into, you've taken this out, so you're going to be left with x. You've taken this out, so you're going to be left with what? Plus sine x. All right. all over 1 plus cos x all squared. All right, now you're going to notice that 1 plus cos s is going to take away 1 plus cos square x from here. Now cos x, sorry, 1 plus cos x is going to take away 1 plus cos x here, one of it here, and then you're going to be left with what? X plus sine x over, you still have 1 left here, 1 plus cos x. All right, so that is where we draw the line, and that's going to be our answer, x plus sine x over 1 plus cos x. All right, so when we differentiate this with respect to x, or when we find the dy dx of this using quotient rule, we're going to have what? X plus sine x over 1 plus cos x, and that will be our answer. Make sure you like this video, share this video, and hit the subscribe button, so when I upload more videos like this, you get notified.